Okay, let's fill in some more notes here, particularly on the bottom. So U9C, how do I know if I'm looking at a quadratic? Well, in our basic level here had to do with studying a table. So if I was going to look at the basic level, this is if the second differences are constant of the outputs are constant. So this was one of our stations that we worked at in the station rotations. I'm going to put just kind of a sample in here and try to leave myself space for the intermediate and the advanced. They don't take up as much space. So let's make up an XY table. We'll keep it real simple. I'm going to go with 0, 2, 4, 6, 8, and 10 here. It's important that these be evenly spaced. They don't have to go up by 2s. They could go up by 1s or down by 3s or something, as long as it's the same thing every time. And so I will use as my outputs 0, 4, 16, 36, 64, and 100. So I'm just going to actually do y equals x squared here. So the first differences, when we look at the first differences, we're going to come in here and do 4 minus 0, which is 4. And then 16 minus 4, which is 12. 36 minus 60 is 20. 64 minus 36 is 28. And 100 minus 64 is 36. These are not constant. They're not the same number. So when I go into my second differences, 12 minus 4 is 8. 20 minus 12 is 8. 28 minus 20 is 8. 36 minus 28 is also 8. These are constant in the second difference, and so therefore, write that out. This is quadratic. If those second differences are constant, then the thing is quadratic. All right, I'm going to squeeze my intermediate in here. For my intermediate, basically what I have is a form where I can see what the degree is. Okay, so for the intermediate, I can see the degree is 2. And degree 2 is quadratic. Okay, so there may be some rearranging into its standard form, something like that. For the advanced, the idea is that the degree is disguised basically because there are parentheses in the problem. So there's some multiplication or some distributive property. Distributive property is multiplication, so there's some multiplication indicated that may be obscuring the degrees, or even some addition and subtraction that I have to do to simplify the thing first so that I can see what the degree of the polynomial actually is. So one place where that happens might be either in the factored form or in a form that we call the vertex form. I'll take a look at the factored form example. So if we had y equals 2x minus 5, and let's go with a 7 minus 3x. And the question is that quadratic? You'll get a sense for these pretty quickly anyway, but this is not a particularly challenging standard. Multiplication we do with the area model. So I'll set up a little area model here and say I've got a 2x minus 5 and a 7 minus 3x. 7 times 2 is 14, and there is one x there. 7 times negative 5 is negative 35. 2 times negative 3 is negative 6. X is from two locations, so that's an x squared. Negative 3 times negative 5 is 15. I get 1x from there, nothing from up there. My like terms are living right there. So this can be rewritten without parentheses as y equals negative 6x squared plus 29x minus 35. The whole point of that is that if it's not in the standard form, then I can't locate my axis of symmetry, my vertex, my y-intercept, my other point. All of this stuff up here is based on the function being in standard form in the first place. It wasn't here, so I can use my multiplication, this intermediate representation here, to figure out that in this case what I would have is that A is negative 6 and the B is 29 and the C is negative 35, and that was a difficult thing to see from here. Okay, so that is the U9C Notes update.